Okay, this is page 534. Parallel lines and proportional parts. It's lesson 7.5. Parallel lines and proportional parts. Let's take a look at the first theorem. It's one that you actually tried to use last week or the week before, I believe, and we hadn't got to it. I made you use the AA similarity theorem, I think, instead. But it says this: if a line is parallel to one side of a triangle and intersects the other two sides, it divides the sides. It divides the sides into segments of proportional lengths. Okay. Thank you, Freely. So this is the one that we tried to use not too long ago. Let me explain something to you. Let's say that we have this side, right? If we take another side, it doesn't matter where it goes, but anywhere along here, and we make it so it's parallel to that side, okay? And this is A, and this is B, and this is C, D, and E, okay? It says, if a line is parallel to one side of a triangle and intersects the other two sides. Okay, so let's take a look at that, just that part. We put this line in so that it was parallel to this side and it intersected this side and this side. Does everybody see that? Okay, then it divides the sides into segments of proportional lengths. Ooh, totally. Okay, so what it does is, if this line is parallel to this line, then AB over BC is equal to AE over AD. And I'll show you how this looks. Okay, so this piece is to this piece as this piece is to this piece. And you remember when you did that a couple, well, actually I think it was SAS, and I made you use the SAS, and somebody asked, I think it might have been Bo, said, well, is this piece to this piece the same as this piece to this piece? And I said, no, use this piece to the whole thing, remember? And then this piece to the whole thing. But yes, that works out later because of this theorem. Okay, so let's assign some sides here. If I go, this is 7.5 and this is 3, okay? And I go, this is 2.5. This is 2.5. I can X. I don't have to use the whole side. All right, so what I can do is I can say 7.5 is to 3 as X is to 2.5. But I got to match the sides. So Harper, you could go 3 is to 7.5 is 2.5 is to X. You understand what I'm saying? In the past, we'd have to go 7.5 to the whole thing, which would be 10.5, to X over X plus 2.5. You see what I'm saying? This allows us to break it up into pieces. Much easier to work with. So now I cross multiply. Can you tell me what 7.5 times 2.5 is?
14.
Use your calculator, please. You would, please?
16 something.
Just to make sure that we get it right.
18.75.
18.75 equals 3x. Now we divide both sides by 3. What do we get x to be?
6.25.
6.25, okay? Do you see that?
Okay.
Yes, Kyle, you have a question?
I'm getting
Do you understand this theorem?
Yeah.
It's a very nice theorem. Makes it a lot quicker than using SAS or AAS. Now this inside triangle is similar to the outside triangle. Do you understand that? And we could use AAA or SAS similarity, okay? But we don't have to, because this theorem allows us to do the pieces. Any questions about that? Okay, very good. All right, turn to the next page, on page 535, and we have the converse. Oh, by the way, this actually has a name. It's called the triangle proportionality theorem. Didn't write that down. The triangle proportionality theorem. Okay, so we also have the converse. The converse of the triangle proportionality theorem. So this is the kind, I abbreviated there, the converse. All right. Now I'm not going to draw this out, but it starts by saying, if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side. Okay? All right. Now let me show you what I'm trying to say. Let's say that I just draw this so it connects. All right? All right? And I say that this is 3. This is 9. And this is 1/3 the length of the whole thing. This is 1/3 the length of the whole thing, x. Okay? Are these sides in proportion? That's the question. This is 1/3 of the whole thing, so this is 1/3 of x. You understand what I'm saying? So is this 1/3
Yeah.
of the whole thing? Right, is this 1/3 of this is 1/3 of this, isn't it? Okay. Is this 1/3 of that? Yes, it is. It's 1/3 of this, because I said it was 1/3 of this. No, not the whole thing. Harper's right. I got my bracket wrong. It should be 1/3 of this. There you go. That's x. If this is the case, okay, then this line is parallel to that line. Do you understand what I'm saying? Now let's go back to how I messed it up before. If this is all of x and this is 1/3 of x, that is wrong.
Should
Right?
be 4th.
It should be 1/4 of it, right? If I did the whole thing,
Be 12.
in other words, I did this, Kyle. I went the whole thing, all right? This is 1/3 of the whole thing. That's not 1/3 of the whole thing, because the whole thing is 12. This is 1/4 of the whole thing. So that is not correct. These two lines would not be parallel. But what I meant to say was that it is 1/3 of from here to here. Now these sides are in proportion, so these two lines are parallel. Okay? You got it? So the converse works. All right, so let's talk about what a mid-segment is of a triangle. Mid-segment of a triangle. Okay, it's on page 535. Is a segment with endpoints that are midpoints of two sides of the triangle. Is a segment that joins two midpoints of the sides of a triangle. Okay? Now, there are 3 mid-segments of a triangle. So if I just take a triangle here, okay? We'll call this triangle A, B, C. You got it? Okay, if I find the midpoint of this, so that means that those two sides are equal. and I find the midpoint of this, so that means these two sides are equal. Let me drop it down a little bit.
Hold up.
Okay, you understand that? Okay. Gigi, you got it?
Yeah.
So this is the midpoint of AB, and this is the midpoint of BC. Got it? If I join those, it's called a mid-segment. It's called a mid-segment. Now, here's one mid-segment. But if I find the middle of this one to be here, and so this is the middle of that, this is the midpoint, and I connect that one, this one is also called a mid-segment. And then if I connect these two, that one's called a mid-segment. So every triangle has 3 mid-segments. Okay? And we have the triangle mid-segment theorem. The triangle mid-segment theorem. There's something special about these. And here it is. A mid-segment of a triangle is parallel to, how does the book say it? Third side? To one side of the triangle. To one side of a triangle and is 1/2 the length of that side. Okay? Now, that means that this right here, the first one we drew, remember the first one we drew? Is parallel to this side. Right? You got it? And really, if this is 6 centimeters, how big is this?
6, 7, oh, it's 3.
It'll be 12.
It would be 12
Oh,
centimeters.
yes, because the top one's half the bottom one.
Exactly.
Sorry, I was busy writing.
That's okay. Okay, so Greta, can we test you again? Okay,
Sure,
let's
I
say
guess.
this whole thing is 11 centimeters. How big is it from here to here?
5.5.
5.5 centimeters. Are you following this, Gigi?
Yep.
What about you, Harp? Okay, so Harp, if this is 4 centimeters, how big is it from here to here? 8 centimeters. That's kind of a neat theorem. Are you okay, Joss, with all of that?
Yep.
Okay. Take a look on page 536. They have another one there. See the drawing? Okay, see the drawing? All right, put it up there. Put it up there. Can you, Josh, you tell me if you can see it. Right here? Right here? Back up, go forward.
Go forward. Yeah, you can see it.
Pretty good?
Yeah.
Okay, so how big is XZ? Looking at that figure.
1/2. Or 6.5.
6.5? And do you know how they get it?
Half of RT.
How big is RT?
13.
Okay, so how big is ST?
14.
14?
X1 is
No,
7.
it's 14 because y to x is 7, so you double that. So ST is 14.
Okay, do you agree with that?
Yeah.
Okay, now here's the kicker. I have to see this one. Angle RYX. RYX. It's an angle. How big is it? Can they see this, John? How big is it?
124.
124. Can you tell me why?
Opposite.
Yeah.
So they are opposite, alternate
Interior.
interior angles. This line is parallel to this line, and that's your transversal. Okay? All right. How we doing? Okay, the last 2 theorems that we're going to talk about it says on the bottom of page 536, it's corollary 7.1, it's proportional parts of parallel lines. If three or more parallel lines intersect two transversals, then they cut the transversals proportionally. Okay, so take a look at this. I'm gonna do it with my marker. Okay,
Come on, John.
let's say that I have three parallel lines.
Mhm.
Here, here, and let's make this one a little further away, okay? Like that. Does everybody get that? And so I'm gonna put this transversal here, like this is called a transversal, and this is called point A, point B, and point C. Does everybody see that? Okay? And so then I'm gonna run this one back this way. And I'm gonna call this point E, F, G. Do you understand that? And these three lines are parallel. Do you get that?
Yep.
Okay. What this theorem says, this postulate, this corollary, it's actually a postulate, but it's called a corollary because it says that AB over BC equals EF over FG. That this length over this length equals this length over this length. Do you see what I'm saying? So, if I knew some of these, if I said, okay, well, this is 6, and this is, looks like about 10, and this is 4, could I find that? X. And how would I do that?
Put
6 plus 4.
6 over 10.
6 over 10 equals 4 over x, right? So I have 6x equals 40, divided by 6, x equals 6 2/3, is that right?
6.66.
Yeah. So 6 2/3, correct? All right. Any questions?
Not yet.
Now, let's take that one step further, that same picture. And I'm on page 537, I'm at the bottom, and this is called the congruent parts of parallel lines. It says, if three or more parallel lines are cut off by congruent segments on one transversal, then they are cut off by congruent segments on every transversal. Okay? So if I have three parallel lines, okay? And I'm gonna make them so if I cut this transversal, that this and this are equal. Okay? So this equals that. You see what I'm saying? This piece and this piece are the same length. If I throw another transversal in there, Harper, then this piece has to be equal to that piece. Now, what I'm not saying, because these lines are parallel, by the way, what I'm not saying is that this is equal to this. I'm saying that these two have to be equal. If these two are equal, then these two have to be equal. All right, for example, if I throw this in your face, if I say, okay, this is I don't know if you'll have one that hard, but let's say that this is 6x minus 5, and this is 4x plus 3. And this is 3y plus 8, and this is 5y minus 7, okay? And I asked you to find x and y. How would you do that? How would you solve for y if these two are equal? We didn't know these were equal, maybe. How would you find for y?
3y minus 8 or plus
3y
8.
plus 8 equal?
5y minus 8.
All right.
Oh, midpoint.
Okay, so we're gonna do that. We're gonna subtract,
Negative 7.
we're gonna subtract a -7 from both sides. We have 3y plus 15 equals 5y, and then we're gonna subtract, whoops, this is a y. We're gonna subtract 3y from this side and 3y from this side, and I get 15 equals 2y, y equals 7.5, right?
Yeah.
Okay. And over here, since these two are equal, these two have to be equal, correct? And so I would have 6x minus 5 equals 4y plus 3 plus a negative. And I subtract -5 from both sides, I get 6x equals 4x plus 8, and then I subtract 4x from both sides. 8 equals 2x, x equals 2. Okay? Do we understand that? I do want to look up something. Okay. Take a look at 24 on page 540. 24.
Is this gonna be in our assignment?
Yes. How much time has gone by on the video?
21 minutes.
21? Okay. Alright, 24. Says find x and y. So we have this picture here, this, and this. Correct?
Yep.
And we have this transversal here. And it says this is 20 minus 5x, correct?
Which one?
24.
Yes.
Right?
Yep.
And this is 2x plus 6, right? And this is y here, and 3/5 y plus 2, correct? And it says that these are equal, right?
Yes.
I think I got it. Alright, so how would I solve for x?
Set them equal.
I would set these two equal. Same with the y's?
Not until you have the
No,
other ones.
it doesn't
We
matter.
could-
Once these are equal, these have to be equal, right? I wanna do this one. Y equals 3/5 y plus 2. Why do you suppose I wanna do that one?
It's harder.
Why is it harder?
Fraction.
As a fraction. Okay? So how do I get the y's on one side? I'm gonna subtract 3/5 y. I'm gonna hurry this up because I'm starting to lose somebody in here that has a lot of hair. Okay? Alright, so I'm gonna subtract 3/5 y from both sides. Alright, so this is plus a negative. You guys realize that this is 5/5 y, right?
What is it for?
Because I get a common denominator, it's 5/5 y is 1 y.
Okay.
Okay, so 5/5 y minus 3/5
So we
y
get 8/5 y.
is 2/5
2/5
y,
y.
if this is 5/5 y. Right?
So
Oh,
it's
yeah, we
negative.
subtract, yeah, yeah.
And this is 2. Now, how do I solve this? Just remember,
Multiply by the reciprocal.
you multiply by the reciprocal. 2/5 y times 5/2 equals 2 over 1 times 5/2. And I get y equals 5.
Oh.
Okay? And I'm gonna stop there because I'm gonna let you solve for x. So, your assignment, and it's not due tomorrow, is it?
No.
Okay. Got that, finally got that right. This period 5, right? Is page 539, numbers 10 through 26, 35 through 38. Okay, 10 through 26, 35 through 38. It's not due tomorrow, okay?